Distillation is a commonly used technique throughout the world to separate alcohol from its impurities. In this experiment, ethanol and water will be separated through distillation, and they will be compared between two types of distillations: fractional and simple. Right here we have the simple distillation apparatus set up, and we're going to go over some of the components that is essential to a simple distillation apparatus setup. So first of all, you need a water jacketed condenser, where it's right here, and you also need a round bottom flask and a three-way adapter. And to record your temperature for every volume and increase of the distillate that goes into this receiver, we have a thermometer right here. The water will go in from here, and it will go out from here. And last but not least, you obviously need a heating mantle, which is this right here. Here we have the fractional distillation apparatus. It is very similar to the simple distillation apparatus, but it is much more efficient, and it has a distillation column set up right here, unlike the simple distillation apparatus. This distillation column has foil over it to contain the heat, and inside, what you cannot see, are glass beads. The reason why there's glass beads inside is for more vaporization condensation cycles to occur, as opposed to it only happening once in the simple distillation apparatus setup. Similarly, as in the simple distillation apparatus setup, in the fractional we also have a water jacketed condenser, the receiver, the heating mantle, of course, the round bottom flask, the thermometer to record temperature for every increase in volume, and last but not least, the water that goes in through here and the water that goes out through here through the tubes. Some basic information about safety when doing simple or fractional distillation and dealing with ethanol. You need to know that ethanol may cause severe eye irritation or moderate skin irritation. It can also cause nausea, so be careful to not inhale the chemical ethanol. For disposal purposes, if you plan to do this lab, you want to dispose of the ethanol in the non-halogenated container. Here we have the results for the simple and the fractional distillation. As you can see, both of the lines on the graph for the fractional and simple distillation are pretty similar up until a certain point, specifically to the point 78.5, as you can see for the fractional here, and for the simple here. As you can see, they're both almost at a plateau until 78.5 degrees Celsius. Then both of their temperatures shoot up. This is because all the alcohol now has been vaporized, and now what's being boiled is the water, which has a much more higher boiling point than that of ethanol. So, to get the percent of alcohol in the vapor, we take approximately the number right before it starts to rocket up or shoot up, which is right about there, and for this, it's right about here. So we'll take at least 10.5 to 10.7. So if you take about 10.5 in a 20 milliliter solution and you multiply that by 100, you're going to get 52.5% alcohol in the vapor, meaning that there is approximately 47.5% water in the vapor, which is a good thing because the ultimate goal of this experiment is to get more percent of alcohol in the vapor than the percentage of water in the vapor. In this experiment, simple and fractional distillation are used to separate a volatile alcohol from a non-volatile solvent. We use both of them to compare the efficiencies of both of them. In theory, the fractional distillation is proven to be more efficient for a few reasons. One, in the distillation column, there is glass beads that increase the surface area in order for more vaporization condensation cycles to occur. And when more vaporization and condensation cycles occur, more of the alcohol is in the vapor as opposed to the water, since alcohol has a lower boiling point than that of water. This means that the water condenses and falls back down into the flask while the ethanol continues to rise and reach the distillation head where the temperature is recorded. As discussed before, this is because the water has strong intermolecular bonds due to hydrogen bonding. More energy is required to break these bonds and allow the water to vaporize, which explains why water has a higher boiling point. When boiling water, it allows the molecules to move around. They are not necessarily vaporized yet at this point. They are only vaporized when they reach their boiling point. This is when the bonds are completely broken. Ethanol, on the other hand, has very weak intermolecular bonds. So if ethanol is just heated to a gentle boil, it will vaporize much quicker than water due to its volatile component. So, with that being said, this is the reason why water boils onto the beads and goes up a bit and condenses back down, while the ethanol continues to go up to the distillation head. The results for the student were calculated to be 52.5% alcohol and 47.5% water in the vapor. Some would say that 52.5% alcohol in the vapor is not acceptable and that the percentage should be a little higher. But this is acceptable because when heating the alcohol and the water, some of the water may also vaporize along with the alcohol instead of condensing back down, which thus lowers the overall percentage of the alcohol in the vapor because there's a small fraction of the water in the vapor as well. For the future, the student should take caution when dealing with the tubes and the water so he avoids a mess with the water. Also, for future reference, the student should maintain a steady temperature that is not too high and not too low. Changing the temperature throughout the experiment too many times affects the temperature readings, thus giving a less accurate data for the students unknown. In conclusion, through the use of the fractional and simple distillation, the student was able to separate alcohol from the water and be able to determine the percentage of alcohol within the alcohol-water mixture. Also, this experiment allows the student to compare the efficiencies between the two distillations.